Good morning, ladies and gentlemen. Welcome to BASF. Welcome to day 2 of K2025 and welcome aboard our plastics journey. It's a little bit of a slow start this morning, so I can only invite all of you who are standing in the hallway to take a seat on our super comfortable and exclusive Elastolan cushions here. Come on to the front because we have an exciting talk for you. We're gonna talk about electrolyzer stacks for hydrogen production, controversial energy carrier and nice material solution. I'm very happy that Rafael Pauli, Vice President of Sales at Stargate Hydrogen, is with us today, and Jochen Schmid from our ultrasound team. Good morning, gentlemen. How are you doing? You came in a little late. All good now?
Yes, I'm all good. So I'm settled now, so I'm ready for the discussion.
Fantastic. So
thank you.
That's good because I'm going to start with you, Rafael. I mentioned it in the beginning already. Hydrogen is a bit of a controversial energy carrier. Why do you at Stargate believe in it?
Yeah, Richard, you're absolutely right. So, I mean, some years back, hydrogen was like perceived as a Swiss Army knife of decarbonization, and everybody was jumping on the hydrogen train. And it's true, you can use hydrogen for many, let's say, applications to decarbonize. But actually, there are ways, or there are, let's say, some things where you use electrification directly, like for battery cars. But on the other side, you need still the molecule. So there are industries that will need hydrogen. So there is no other way. For instance, if you want to produce methanol, green methanol, or ammonia, or green steel, or maybe also heavy-duty transport, then you need to rely on hydrogen because there is no other way to decarbonize that industry in an economic way without hydrogen.
Okay. And what are the kind of most important challenges that you're facing in also scaling this up and making it count for the industries that you mentioned?
Yeah, actually there are many challenges that we had to overcome, but clearly one of the major challenges is the material of the electrolyzer stack. You can see it on the picture, and in yellow you see the frame, and the frame is exposed to a KOH solution, which is a very corrosive medium, and of course there are solutions also like steel, but steel is, for instance, it's really heavy, and it's not easy to manufacture on mass manufacturing, and also the costs play a large role there.
Okay. And that's why you decided to explore the polymer field for this.
Yes, exactly. So we were reviewing polymers, and we see a big advantage, especially on the, let's say, it's good to use it in corrosive environments like the KOH. For instance, in the electrolyzer, we have 25% of KOH solution, so the electrolyte, which is very aggressive. And on the other side, there is also the question about the weight. So we want to put our stacks in a container, and I mean there is some limitation on the lifting equipment for those containers. We have recently launched a new product, a 5 megawatt stack, which is like it could be in a container, and that's why we need a lightweight solution. And just for comparison, a stack based on polymers is around 30 tons. If you do the same on
30 tons.
30 tons.
Wow.
This is a lightweight.
Okay.
But this is still fine. But if you do it in steel, then you have around 60 tons.
Wow.
And then you have an issue also in exchanging stacks on site.
Yeah.
So you need to lift them, remove them, handle them, transport on the road. So that's why lightweight is crucial for us.
And in the end, that also plays into the whole sustainability topic. Yeah? If you need additional lifting equipment, if you need additional transport capacities to carry them, doesn't make it more sustainable in the end. Yeah? Right.
You name it.
Yeah. Jochen, Stargate chose polymers for this application, and a specific one. Which one?
Yeah, so for this application of the frames, as you can see here on this stage, and exhibited on the other side of the booth, Stargate used our Ultrason S.
Oh yeah, right. We don't have it here because it's too heavy. Yeah,
too heavy.
You can see it on the other side of the booth.
Tried to carry it, but I'm a little weak about it.
No, don't do it. Don't do it.
It's the Ultrason S, the polysulfone, which actually proved to be a suitable material, and I think we also got aware of the fact that applications out of polymer are important in the segment of hydrogen, and so it was our pleasure to work together with Stargate and to, check and evaluate what is actually necessary to fulfill the requirements.
Yeah, and what is necessary to fulfill the... You said it's a suitable material, but why?
Yeah.
Why is it suitable?
Yeah, actually, I think that is a good question to address here. As you talk about electrolyzer stacks, you need to fulfill, or your material needs to fulfill several different requirements. And first of all, I think there's the chemical resistance to mention. So you have this electrolyte environment, and if we talk about alkaline electrolyzers, you have a strong base environment. If you talk the proton exchange membrane electrolyzers, you have a really acidic environment, and you need to actually prove that your material can withstand this environment. But at this very same time, you need really high mechanical strength at elevated temperature. So we have done tests above 100 degrees Celsius, so to be a little bit about the operation temperature. And then the creep resistance, I don't want to forget here about it. As you see the stacks and the really strong bolts, I think you get an idea what force is actually applied to the stacks, and they have to they can, of course, deform in any way.
I imagine that there's a whole lot of testing, fine-tuning involved also between the two companies in order to actually make it happen, yeah?
Yes, indeed. So as we need to have the stack certified, we need to do a thorough investigation of the material, of course. And as this was also like a new step for us going into this polymer, we discussed a lot with BASF about the, let's say, properties of the material itself, and we have been also receiving small samples where we, for instance, we boiled them in KOH. These samples, we made some destructive testing. So this is really crucial to get the certification of the material at the end.
Is this type of testing that Rafael just described, is this kind of a normal ultrasound testing procedure, or was it special in this case?
Yeah, so I would start actually a little bit at the beginning. It was actually really cool at the beginning because we were involved rather at the early stage. So we started with the, let's say, kind of standard procedure of showing Stargate and what the performance of our materials. And there's probably a lot of the standard material testing we have, and also our material testing lab, I really want to mention, did a great job there. But then accompanying this project, you just learn so much about the application and the specific requirements that we actually also have done then specific testing, and that was mainly actually testing our material in the specific and distinct electrolyte environments, as we have talked about it. So, for example, testing our material in potassium hydroxide at 120 degrees C which you might be a little bit concerned at the beginning if any polymer withstands that, but here we see no degradation in ultrasound S as well as a PPSU, and also then as we talk maybe in a minute about the certification, we have done special tests about that as well.
We get back to the topic, or we come to the topic of CE certification, but now Jochen described that he, or the ultrasound team, the BASF team, has learned a lot about electrolyzer stacks. What did you learn about polymers in that process?
We learned, I mean, that they can withstand like these caustic environments. So this is very important for us. That you can, let's say, do the geometries that we need for the stack. So there are certain flow channels that we need to have in the frame. And before it was like, let's say, furnished out of one metal piece, but now we can also see we can do injection molding of this polymer. And this was very good to see, and this was as per our planning then at the end.
Now let's come to the topic that you already brought up, Jochen. Of course.
Jump in here
please.
Because I think actually it was also then if you talk about requirements and the testing, I think then the other topic we had a few discussions in between is then also processing our materials. So I think we know how to process them, but also that is something we had a nice learning about processing such big parts. And I think here we had a really close discussions and could even also give here and there some support just at the end to get ideal processed parts at the end, because that's then important that they parts have to actually fulfill the whole requirement. So
can I ask the two of you how long it took, the whole process, basically from the first idea, let's try this, to it's there?
Yeah, that's a good question. I don't have the date in my mind, but as it was working with such a dynamic company, it was rather quick, I would say. I think the first contact we had, I don't want to lie, probably like 1.5 years maybe,
okay,
but not much longer. Yeah.
Very good. So let's come to the topic of certification, because these parts need to be CE certified. Is that correct?
Yes, so we're a company from Estonia, so we are in the European Union, and the majority of our customers, they are located in the European Union. And if you want to build an electrolyzer, then our clients need to have a permitting. And the special requirement of this permitting is to have a CE certified equipment, and especially for the electrolyzer stack, it needs to be per the Pressure Equipment Directive, the PED certified, to receive the CE marking of the equipment. And of course this was very crucial, and I can also tell you that it was also new for the notified bodies. So you don't do this every day at the notified body, so it was also crucial to receive those testing data, and they also help in the let's say calculation of the material properties.
Is this something that you normally also offer as support?
Yeah. Again, so I think the support really starts from the very beginning, the material choice, then the accompanying the whole project until the certification process. And I'm really happy that actually we were able and had the opportunity to support Stargate, as we actually did testing in our certified material lab of BASF. So a compliment to the colleagues, which actually also here on the booth, and a big thank you to them. And actually with this certified report from our material testing lab, I think it helped Stargate quite a bit to get this CE certification.
Yes.
BASF and Stargate, you also published a joint press release on that topic, and I saw that this created quite some excitement also in the media. So you mentioned hydrogen was a hype topic some time ago. For me, it still seems to be a hype topic. So what's the future?
To me, it's getting from hype to a realistic scenario. We see that with hydrogen, we will not see the full decarbonization worldwide.
Yeah.
And of course, for this one, we need new technologies. We invest a lot in R&D. We develop new products that also bring down the costs for our end clients, and at the end, the cost for producing hydrogen. And of course, we need to rely on a strong partner network, and BASF is one of those partners at Stargate.
Okay. Jochen, from your perspective?
I can pretty much echo Rafael's first word. I think we experience pretty much the very same as from this big excitement now, and a lot of requests. I think now the requests and the projects slowed down a bit, but they are not cancelled, and so we continue to work with them. But in general, I'm fully optimistic about that the plastics, and especially now talking about the polyaryl ethersulfones and the ultrason grades, they have definitely a future in this application, in the segment, as we have talked about it, due to this outstanding properties of the material.
Well, I think that's good. Let's end on an optimistic note. Optimistic about the future of hydrogen, optimistic about the future of plastics for electrolyzer stacks in hydrogen production. Thank you very much, Rafael. Thank you very much, Jochen.